Hi everyone, this video will teach you how to find all zeros of a polynomial function. This is going to be a follow-up to the previous lesson on finding rational zeros, in that in this video, all of our zeros could possibly be a mixture of rational, irrational, or imaginary numbers. So, let's take a quick look here at a couple of reminders about how many answers we can find within our particular functions. If we take a look at number one, I've got a polynomial function here, x to the fourth minus 2x cubed minus 19x squared plus 8x plus 60. Question number one says, what does the degree tell us about the zeros? Well, as you've learned in previous lessons, my degree tells me how many zeros I can possibly have. Because I have a degree of 4, there are going to be 4 zeros in this function. Now, what those answers could be, again, it could be a mixture of rational, irrational, or imaginary numbers. Let's explore a little bit here from a graphical perspective. If I give you a different function, something like x cubed minus x squared minus 7x plus 15. Take a moment, enter that into your graphing calculator, and let's take a look at what the graph will tell us about the zeros. We know from just the degree itself, it's a degree of 3, so we know there are 3 zeros. But from a graphical perspective, so I've already went ahead and entered the equation in, as you can see. If we take a look at the graph, it's very obvious that it crosses the graph at one place here on the x-axis. It looks like it's at -3. If I go to my table here, I can verify that I do indeed have a 0 at -3. But if I were to scroll through this table, I wouldn't have any other zeros. Now, that doesn't mean that there aren't any other zeros. It just means maybe these are fractional values, maybe they're irrational, maybe they're imaginary. If I go back to the graph, I can see that on the left side, it looks like it's ascending, it's going up. I know I'm way off the screen here, but you can see here, I can scroll up a little bit with my calculator. Comes to a maximum point, falls back down, and then goes back up on the right side. After the graph crossed at x equals -3, it never crosses the x-axis again. So what do we have in this case? Well, we have one real 0 at x equals 3. But again, this is saying based on the degree, I should have 3 total answers. Because it never crosses the x-axis again, what that means is my other 2 zeros are imaginary. Because we have to find a way to get all 3 answers, it means the remaining answers, since they don't actually cross the x-axis, they're part of the imaginary set of numbers. So whenever we see some of these problems here today that have an imaginary component to the answer, when you look at their graph, that means they're not crossing the x-axis as many times as the degree states. That is just something to keep in mind from a graphing perspective and how it can relate to your algebraic solving. The math that we're going to do here today is very similar to what you did in the previous lesson, which is simply we're going to use our graphing calculator to figure out at least a possible 0 that we can use to kind of make our function smaller to work with. And then we're going to use what we know regarding quadratic functions as to how to make these easier to solve. So let's go ahead and take a look here at a few examples. So this all connects here to what we call the fundamental theorem of algebra, which is basically what we've kind of been talking about all chapter. The degree of the polynomial tells us the exact number of factors. This will include repeated factors. This includes complex and imaginary factors. It's all types of answers that can humanly exist. So let's take a look here at the function that's given, x cubed minus 4x squared minus 5x. Let's go ahead and find all the zeros. So first thing I'm going to do here is go back to my graphing calculator and plug this thing in. So we can see the graph of it. Looks like it's crossing 3 different times here on the x-axis, which kind of makes sense because, again, it's a degree of 3 function. We'll go to our table. Let's see what kind of zeros we can find. And it looks like we can find a good amount of them in here. Looks like we have zeros at -1, 0, and also at 5. Now, using algebra, let's verify that these indeed work. As you may recall from the previous lesson, the way that we verify that a 0 indeed is a 0 is we use our good friend synthetic division. So, from my calculator, it tells me my zeros are at x equals -1, 0, and 5. So let's go ahead and start with the -1. Do a little synthetic division here. Now, my coefficients are 1, -4, -5. You'll notice there's no constant term at the end. That is a great place for a placeholder. We'll put a 0 here in our final column to represent the constant. We'll repeat the same process we've done many times over. Pull down the first number, multiply the number at the bottom times the -1, add the column. We'll multiply again, add the column, multiply, add. My last digit is 0, so I know -1 is indeed one of my answers. That's good. I'm going to go ahead and continue to do synthetic division. I'm going to stack it, as you saw in the previous lesson here, whenever you have multiple zeros available. That way we can just keep narrowing down our answer. I'm going to go ahead and plug in 0 now. So we'll multiply, add a couple of times. Once again, I get a remainder of 0. That's all good. Now we'll plug in 5. Do the same thing. Once again, I get no remainder. So algebraically, I've now verified that all my zeros are indeed good. My solution set would indeed be x equals -1, 0, and 5. Now, admittedly, most of the problems you're going to get will not be that simplistic in that all of your answers are going to be right on the calculator. This is certainly one of the easier versions of this kind of problem. But at its heart, we're going to use synthetic division with answers that your calculator can give you. If there are still answers remaining, we will use, like I've said, quadratic formula, completing the square roots, factoring in order to solve for what's left and what your calculator can't tell you. Okay, so there's a few more examples here that we're going to go through. Let's take a look here at the next page of notes. So in number 4, we're going to reconsider the function from one of the earlier problems, x cubed minus x squared minus 7x plus 15. Let's go ahead and use the rational zeros test to find all possible rational zeros. So this is going to go to the previous lesson here. As you might recall, the rational zero test is when you take the factors of the constant divided by the factors of the leading coefficient. In this case, my constant is 15, so my factors would be 1, 3, 5, and 15, while my leading coefficient simply is just 1. We put a plus minus with all of these because, again, you could have positive or negative factors. There are 8 possibilities in terms of a rational answer. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Now, as we talked about yesterday, you could guess and check all of those answers. Something's going to work out of those. But the thing is, not all of them will work because, again, it's a degree 3 problem. You're only going to get 3 answers. Plus, it's also possible, again, you might have an irrational answer. You might have an imaginary answer. Those are not going to be part of the rational zero test. So, while this, again, can kind of help you to see, where some of your answers might lie, it doesn't quite give you everything. This is why your calculator is going to be most beneficial. Now, I could go plug this back into the calculator, but we did look at this problem before. We did find, if I go back to number 2 here, one of my zeros was at -3. I'm going to go ahead and plug that in and do some synthetic division. So let's go ahead here and set that up. So again, a lot of multiply, add. That'll get me to a remainder of 0, which is good. Now, since that was the only 0 that, again, was available on our calculator, I'm going to go ahead and take the function that's left, starting with, again, I had an x cubed function. I divide out a singular term from it. It's going to knock it back to an x squared. So I have x squared minus 4x plus 5. We're going to set that equal to 0 to go find our other 2 solutions. Now, you might look at this and say, oh, I think that's going to factor because this is a number combination, depending on your signs, that might actually work out. I'm going to save you some trouble here. You can try to figure out what multiplies to 5 and adds to -4. It'll take you your entire life to figure that out. This isn't going to work by factoring. Your best option here is to do quadratic formula. So, as a friendly reminder, as you're doing this throughout the notes here, or your homework. Here's your quadratic formula off to the side. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's go ahead and do quadratic formula with this problem here so we can get our two remaining answers. So I'd have negative 4 plus or minus negative 4 squared minus 4 times a times c. So it'd be minus 4 times 1 times 5 all over 2a, 2 times 1. Let's go ahead and simplify this a little bit. So I'll get 4 plus or minus the square root of negative 4 all over 2. I can simplify the square root of negative 4. That can become 2i. All of my terms are divisible by 2. So my final solution to the quadratic formula would be 2 plus or minus I. So keeping in mind I had my solution of negative 3 from before. 2 plus or minus I, that's 2 more solutions. That gives me the 3 total that I need. So my final answer, x can equal negative 3 and 2 plus or minus I. Again, if we went back to that previous example, we established that 2 of my zeros had to be imaginary because they doesn't actually cross the x-axis enough times. So again, that's why it makes sense that we have I as part of our answer here. So a lot of this is the same process as you learned previously here, just our answers are not going to be as clean. So there are several more examples I'm going to go through here in the video. Again, you can feel free to take as many of these down as you need to. I'm just going to remind you of some of these different solving strategies that you might need to come across. So let's take a look here at number 5. Same idea. Let's go to our calculator. Notice again, I'm not asking you to do the rational zero test with all of these. If I just tell you straight up, go find the zeros, I don't need you to show me the rational zero test unless you want to have that there as something to check. We're going to go ahead and plug it into the calculator. I can see from my graph that it's crossing the x-axis 3 times, so I should get at least 3 real number answers. I'm going to go to my table here. Found a 0 at negative 3. So again, from the calculator, I get a 0 at x equals negative 3. Let's go ahead and do some synthetic division with that. If you do that correctly, here's what you'll end up with. Pull down the 1. No remainder, which again is the goal. I end up with the function x squared minus 7. And I'll set that equal to 0. So, with this particular function that's left over, this factor, the math I'm going to have to do, we're going to use much more basic algebra. I only have one type of x. I just have an x squared. Remember, if you just have one type of x, I can do normal algebra inverse operations to get x by itself. I'm going to go ahead and add 7. Then we're going to square root each side. Because I'm square rooting each side, we need our plus minus. Square root of 7 is not going to simplify at all. That gets me my remaining 2 answers. So overall, x will equal negative 3 and plus or minus the square root of 7. I do have a few more examples here on the next page here. So again, if you need to keep going with these here, please feel free. We'll see a mixture here of some irrational and some imaginary as we go through. So same process here in number 6. Let's go ahead and put in this function here, x cubed minus 4x squared plus 2x minus 8. If I take a look at the graph, again, I can clearly see it's crossing the x-axis once. It's a degree 3 function, which that's going to be my clue of, hey, my other 2 answers are going to be imaginary. Let's go to my table. Crosses nicely at x equals 4. So again, we'll start using that 0. We'll do some synthetic division and go from there. So the function I'm going to be left with is x squared plus 2. I'm going to set that equal to 0. Same deal as number 5. Basic math. I can use basic algebra to undo the problem. We'll subtract the 2. We'll square root. We'll need the plus minus because I'm square rooting. There's a negative underneath my root. I want to pull that negative out as an I. Can't do anything with the square root of 2. So that's as simplified as my answer can get, plus or minus I root 2. Once again, plus or minus I root 2 is 2 of my answers. The 4 was my third answer that I started with in the first place. So my final set of solutions, 4, comma, plus or minus I root 2. In number 7, we have x cubed plus 2x squared plus 5x plus 174. Now, in this particular graph, you don't see a whole heck of a lot. You can definitely tell it crosses the x-axis once. If I zoom out here, because I have the luxury to do this with this calculator, even so, look how far it goes off the grid here. I can't really quite tell. So we're going to fix my axes here a little bit. Can't quite tell if it's going to have other places to cross the x-axis or if it's so high or low off the graph where it turns that they're going to be imaginary. We can assume that they're probably going to be imaginary because you would figure reasonably, even if I zoomed out to 1,000 on each side of the x-axis, it would cross somewhere. Doesn't mean that's guaranteed, but I think it's going to be safe to assume that we have one normal looking 0 and 2 imaginaries. So where's that 0 at? Scroll through the table. Looks like it's at -6. So let's go ahead and use that. So again, here's my synthetic division. This will leave me with the function x squared minus 4x plus 29. And we'll set that equal to 0. So here we have more of our typical quadratic function where we have two different types of x's. We will certainly want to use, again, quadratic formula with this. Again, especially if we operate under the assumption that it's imaginary, we're not really factoring expressions that give us imaginary answers. Let's go ahead and do quadratic formula to figure this out. So again, negative b plus or minus the square root of b squared minus 4ac all over 2a. So simplify, that would give me 4 plus or minus the square root of negative 100 all over 2. The square root of negative 100 is 4 plus or minus, that would give me 10i over 2. They're both divisible by 2, so I could simplify this as 2 plus or minus 5i. There's 2 of my answers. We had the -6 before. That gets me all 3. So my final solution set, x would equal -6 and 2 plus or minus 5i. The last of my examples here for this video. Let's go ahead and take care of number 8. So we have x cubed minus 8x squared minus 12x plus 16. So I look at my graph, it's crossing the x-axis 3 times, so at least all of my answers will be real numbers. Again, they might be rational or irrational, but at least they're all real numbers. No i's involved. If I go to the table, I can see that it crosses at -2. So I know from my calculator I've got a 0 at -2. Let's go ahead and start there. If I do all that correctly, you'll be left with the function x squared minus 10x plus 8, and I'll set that equal to 0. Now, this problem here, again, I could do the same thing as I did before. I could do a quadratic formula, and there's no problem with you doing that. However, if you're looking to try something a little bit different here, just for the sake of being different, this actually isn't a bad problem to complete the square with. Just for the sake of reviewing how to do that, I'm going to actually solve this by completing the square. If you want to do this by quadratic formula and get the same answer, fine with me. Friendly reminder, to do quadratic formula, you get it so that you have your variables on one side, you get your constant on the other. On each side, we're going to have to tackle on what we call that mystery value that's related to the term that's connected to the x. So in this case, it's a negative 10. We take that negative 10, cut it in half, then square it. That'll put a 25 on each side. What that allows me to have is on this left side, this is a perfectly factorable trinomial, x minus 5 squared. The right side I would just add together and get 17. You would square root each side, get x minus 5 equals plus or minus. I can't do anything with root 17, so I'd leave that alone. Add the 5 over, and you'll get your two other solutions. So in total, you got your three answers, x equals negative 2, and the 5 plus or minus root 17. That is how you find all zeros of a polynomial function. So again, very similar to the previous lesson, just expect to have some uglier answers depending on the functions that you are given, and use your graphing calculator to kind of predict and know what to expect in terms of the different types of answers you can get. As always, if you have any questions, let me know. Otherwise, thanks for watching.